All right. If you want to go, take it away.
Thank you. Hello, everyone. My name is Oscar Resto, KP4, Radio Fox. I'm with Jose Nieto, Echo Alpha 5, Hotel Victor Kilo. Jose, as everybody knows, Jose Nieto is actually the developer and the creation of VARA that had changed everything in communications, at least in the amateur world, about the speed of transmitting data on our rules and regulations with the FCC. Just to give you he was going to talk about himself, but just to give you an idea how dedicated he is with us. He is actually 3 o'clock in the morning in Spain. So he's with us actually very early in the day and has to wake up all night to be here till night with us. So, sin más preámbulos, José, es todo tuyo. Buenas noches.
Hello, good night here in Spain. Good afternoon in USA. Aloha, Hawaii. My name is Jose Alberto. I am the bar outdoor. I am hand with license since 2011, and I studied bachelor 4 years and telecommunication engineer for 5 years. My subject I study in the engineer, and the main subject is this subject, digital communications and digital signal processing was the most important for me. This is the book of digital communication by Bernard Sklar. This book is like ¿cómo se dice Biblia? Bible.
The Bible.
This is the Bible of the digital communication, and it's the most important book in the university for me. This is the prehistoric VARA. When I was studying in the university, I did my first ¿cómo se dice? Incursiones.
Incursions and research.
My first experiments with digital communications. I built this ¿cómo se dice? Placa?
Board.
This interface. He used a micro relay, and this is a voltage comparator LIN339. Is a chip with 4 voltage comparator, and this was connected to a CB rig, a President Taylor, and using the serial port, I create my first digital communication system. This is the board. This is how the signal is, what frequency shift modulation. The square signal was created using 2 charts of AC charge rigs. The charge 21 with the stop bit and a start bit, you have a high frequency tone, and using the you can have the low frequency tone, and with this charge I can have a square signal and create the first frequency shift modulation. This was very prehistoric, but it's worked. Here, and I with 20 years ago, when I was working in this project in the university. This here is, ¿cómo se dice? Medidores estacionarias.
Viendo sí, standing vibration.
Okay. And the CB rig and the supply, DC supply. Okay, and VARA comes from the man of the VARA. The man of the VARA is a Superman Spanish version parodied. And this is the VARA is the stick, and he is the name of VARA. It's a Superman parody. VARA motivation. Chat communication had not sense in the present hard radio work. You have all the info previously, the QSO. You can look in internet what person you are communicating. Some modes need internet for synchronization, and the information transmit is not relevant. So for me, this kind of communication has not any interest for me. However, in emergency communications,
Emergency communications. Emergency communications.
Emergency communication. Comms. And emergency comms is you back to the 80s hard radio sense, but using the latest digital techniques. Internet of telephone is not available, and the modem must to synchronize by itself, obviously, and the information sent is valuable. And this is the reason which I am here. Okay, my friend Luis.
You jump one slide.
Excuse me?
Brincaste un slide.
No, es que la he cambiado.
Okay.
Estoy en el orden. It's okay. My friend Luis, Eco Alpha 3, Oscar, ¿la G cómo se dice?
Golf.
Oscar Golf. Sunday, by telephone asked me if it's possible to send emails from a chat of his friend in the Barcelona Ibiza path. Then ¿cómo se dice? Despertó mi interés.
My interest was awake.
Okay, my interest was awake by the modern communications with no internet. Then I start working in the web, and I contact with Winlink, and in 2017, Lord Kupchins approved VARA in Winlink. Then since this year, I have been working in perfección, ¿cómo se dice perfeccionar?
Improvement.
In improvement VARA. And presently, this is the list of VARA software. You have VARA high frequency for high frequency bands, VARA frequency modulation for 2 meters and 70 centimeters. Okay, bands, VARASAT for satellite, VARA chat, and VARA terminal. And now we are speaking about VARA high frequency and VARA frequency modulation in this presentation. One moment. Also, I think we have here to Joe Speroni, the Hawaii manager, that I think he wanted to tell about VARA frequency modulation and the area RE boards. Isn't it?
Joe, are you still with us? He's not, no están aquí, José. Joe no está por
Okay,
alguna razón.
no problem at the end. Okay, VARA test data, VARA high
Oh,
frequency.
Hold on, un momentito, José, que Joe llegó. Joe,
Okay.
can you talk about the VARA frequency modulation?
Well, all I can say is that it's a fantastic product. We have about 20 gateways here in Hawaii now and expanding. The performance has really caught on, and I think a lot of people are starting to recognize it as important for emergency communications. But this is Jose's presentation. I think I'd like to stay silent.
José, que es tu presentación y ya dijo que era excelente y que prefiere estar callado. Eso es lo que dijo yo.
Vale, perfecto. Okay, VARA high frequency is a high speed, high frequency modem based in OFDM modulation. The maximum symbol rate is only 94 bits per second. Is the signal for operation within bandwidth of 2,300 Hertz, providing uncompressed user data rate to 7,000 bits per second, 16 speed levels, and turbo codification. FCC specific 300 baud symbol rate limit. Is a handicap or is indifferent? Now we will see. Symbol rate is not a limitation for baud rate. This is how VARA of FDN spectrum using orthogonally spaced overlapping subcarriers. Note that subcarrier nulls correspond to peaks of adjacent subcarrier for not have intercarrier interference.
Dame un brequecito, dame un momentito, José. Guys, Jose wants, if someone has a question halfway of the presentation, you can make it. And this is the heart of VARA. So if somebody wants to discuss why with such a low baud rate of maximum baud rate of 94 bauds per second, he can get 7,050 bauds per second in data. This is the way VARA works. So this is the time to make the questions. If somebody wants to raise a hand, this is a good time. George.
I'll bite. That's exactly the question. How are you multiplexing this, or how are you getting that much more data in there with that restricted rate?
José, ¿me permites explicarle?
Sí.
Okay, George, this is the reason I stop here, because normally you have two tones and each tone is like, it will be like we're sing about and we're limited by the FCC rules and regulations for 300 baud. But here, with only 94 up to, because he used much less, up to 94 bauds per second, you can have up to 42, 49 actually subcarriers within one baud. And they're adjacent one to the other one, transmitted at the same time, but they have to be properly aligned, as you can see in the graph, that the subcarriers of the main carrier, of the peak carriers, are not, Jose perdí el screen, are not interfering, making interference. And what he's showing now, that with a symbol rate of 23 and 32 carriers, you can have 18 baud per second, which is level 1. But at the same time, if you go into level 16 of VARA, and VARA is adjusted depending on the signals across the atmosphere, radio, all kind of noise, with 42 symbols in each baud, and at 42 symbols, I mean 42 baud, you can have 49 carriers adjacent to it. You can go to 7,050 baud per second. Does that answer your question, George?
More or less, yeah. So essentially, we're carrying multiple bits at the same time. We're not individual bits per second. We're sending words that might be as big as effectively 49 bits.
That is exactly what is happening. And this is not compression. This is actually, it becomes a symbol each bit, and the symbol can carry multiple data. And people on the chat is saying that it's amazing. This is the heart of VARA. So let me go back to Jose. And that is out of the box, really good, amazing.
I have one more question.
Adelante, Sabi.
Yeah, back to the chart that you had a couple of slides ago.
Jose, ¿puedes ponerle el chart de los multicarriers, por favor?
De los niveles.
El de los niveles.
Okay.
Sí, el de los niveles.
Yes. So if you have a symbol rate of 42, I expect that would be characters, or BPS rather, with 49 carriers. What, I suppose physics, but what keeps you from actually having a symbol rate of, let's say, 200, 250, or even 300 bits per second? Or, yeah, per second.
Because those are symbol rates per second. And
I'm sorry, I meant to say symbol rate at a 300 symbol rate per second.
That is much above the possibility due to the power limitations. He can have up to 42 in the VARA HF at wide, I mean 2300 hertz. He can get symbol rate of 42 symbols per second with 49 carriers, and that will give you that 7K of data transfer. Because he also have a graph that it limits how much power you can have to get the signal to noise ratio to read it on the other side. So it's related to that, but these are workable symbol rates.
Thank you.
Adelante, Jose. Oh, there are two more questions. I'm sorry. Dan, can you? Joe, what is your question?
Oh, hi, Jose. Yes, I wanted to see how this protocol compares to something like JS8 call, and in terms of Shannon limits, if you had any thoughts in that area.
Es Oscar, pero le vamos a hacer la pregunta a José. ¿Cuál es el protocolo? What is the protocol that you're talking?
Oh, JS8 call, which is a variation of FT8, but in QSO mode.
I don't think we have the answer. José, ¿tú entendiste la pregunta?
No.
JS, I should write it down.
JS8 call, yeah. So that's it's really a variant. It's a fork of FT8, which is the optimization of code for distance and signal to noise, as opposed to speed.
I know the answer for that one, Joe. Let me answer, Jose. Level 1, it will compare to it.
Okay.
VARA software can go with VARA HF 2300, it can go from level 1 to level 16. Do you see that on the screen on the left side?
Yeah.
So it automatically measured the signal to noise ratio, the rate from both radios in both sides, and figure out the software what is the best level of VARA to transmit the maximum amount of data within the conditions of the noise level, mean atmosphere, antenna, power, rate, every noise.
Yeah.
From station A to station B.
Does this work below the noise floor? In other words, like I think it's a 20 dB advantage over JS8 call has over FSK.
José, preguntas que si esto puede trabajar debajo del nivel de ruido de 20 dB.
Es que el ruido, bueno, the noise depend depende de cómo midas el ruido. Tienes que tener un ancho de banda de referencia.
So he said that the noise level depends on the bandwidth that you're using.
Right, the data rate, yeah. So I guess, how slow can you go, I guess is the question.
By the way, in a previous presentation that I was talking, actually in an agency that Jose was talking, they were having 11 dBs in VARA FM, and they were getting slow speed, but they were able to transmit files. So it does,
good.
It does goes that low.
Good, that's the question. Yeah, that you answered it. Okay, that's good.
Adelante, Jose.
Thank you.
Okay.
Thank you.
One moment. Okay, this is again the OFDM modulation. This is the frequency domain, and this is in the time domain. You can see the symbols, symbol 0, symbol 1, symbol 2, symbol 3, and the orthogonal subcarriers.
May I explain that? José, ¿me permite explicar eso?
Sí, explícalo mejor tú.
Dale para atrás un slide, por favor.
¿En este?
Sí, ese. What he means with the orthogonal peak carriers, you will have the main carriers, but they have to be aligned properly. And this is, again, in the book of Dita book that he followed, he have to follow the mathematical rules. So you will have the main peaks and you will have the subcarriers. If you see the center carrier, where it has the arrow, you will have subcarriers in this olive green color that goes sidewise up and down the main frequency. But the next adjacent peak is aligned at the null of the subcarriers. So when it's aligned at the null of the subcarriers, it doesn't interfere these adjacent subcarriers with the main peak, because all of them, they are aligned properly. So he have to do the mathematical alignment to minimize the interference of each subcarrier with the main carrier. So this is amazing what he has been able to apply and put it to work for us. Adelante, Jose.
Yeah. The same you have said, here you can see how the multi-carrier and OFDM, how in the OFDM the subcarrier are more joints, más juntas.
See, they are joined together.
Joined together without interference. In normal multi-carrier, you have to have a separation. Okay. Advantage of the DN multiply the delay space tolerance, immunity to frequency selective fine channels, efficient modulation and demodulation, high transmission bit rates, flexibility, easy equalization. This is the easy equalization. This is the most important feature. High spectral efficiency. This is what we have explained here. High spectral efficiency, because the subcarrier can be together. Pueden estar muy juntas. ¿Cómo se diría, Oscar?
They can be together.
Okay. Resiliency to RF interference and lower multipath distortion. Here we can see why with single carrier, we have large distortion for whole spectrum, and with multi-carrier, we have simple attenuation for each narrow spectrum. This way is very easy, the equalization. Okay, now we are going to see what is the fact. Forward error corrections. In the forward error correction technique, code bits are added to the information bits, creating redundancy in the transmitted symbols. For example, here we have 7 information symbols, and we have added another 7 redundancy symbols. And then in the resection side with the redundancy symbols, you can recover the original signal even if any symbol has been destroyed by the noise or by the path.
Interesting.
There is some kinds of fake codes. Old school are block codes. ¿Cómo se pronuncia codes? Códigos?
Codes.
Codes. Block codes, convolutional codes. And in the new school, turbo codes, since 1993, it was a revolution because this code is very near the Shannon limit. Here a comparison. This is code system, and when you add FET codification, you have better. You need less power for the same rate. Here you have convolutional, concatenated, better than convolutional, and finally turbo, that it was a revolution in the FET codes. Very near of the Shannon limit.
So guys, what he's saying that with less power, you can get a faster bit rate with this apply of the turbo code, and this actually this engineering the application. So you don't need more power to get the speed, and because it's you utilizing the efficiency of the spectrum.
Okay. And turbo codes are applied in data space, mobile radio, digital video, terrestrial wireless, satellite, but it's not practical for real-time voice. And of course, are used in VARA. Okay, some question here?
Preguntas hasta aquí, questions up to here.
Question.
Yes.
Go ahead, Craig.
With QAM, quadrature amplitude modulation, the implication is you have to know the maximum amplitude of the carrier so that you can tell the different amplitudes of the bit patterns. If you're struggling with equalization, how do you do that?
¿Entendiste, José?
Traduce, por favor.
Con el 32 QAM, necesitas ecualizar la intensidad, ¿cómo tú resuelves ese problema?
Oh, okay, I understand. Yes, QAM need equalization. This equalization is done using pilot symbols. The pilot symbol are used as amplitude and phase reference.
The which symbols?
Pilot symbols.
Pilot symbols, okay. But how do you deal with selective fading? How often how many pilot symbols do you have in the QAM? I mean, in the OFDM?
Entonces, Oscar.
¿Cómo tú trabajas y resuelves el problema de cuando tienes el fading, cuando se ocurre el fading selectivamente? Y eso es cuando, me imagino que está hablando de esto, de la distorsión, de la atenuación local o parcial.
No, yes, él está hablando de esto. Okay. When you have fading, if you have fading in one subcarrier, you have fading in the pilots.
¿Cómo resuelves el problema?
¿Cómo?
¿Cómo resuelves el problema?
There is not any problem. You only have to do the equalization using the pilots. Well, if with fading and modify the amplitude, the fading also modify the pilot amplitude. So the pilot reference is the same.
That implies that the channel fading has the bandwidth of the separation of the carriers, and that means you're going to have to drop back in the number of carriers if you've got channel problems. Okay, thank you.
This can get really complicated. I think we can put those questions at the end or in an email so it can be answered.
See.
But those are interesting questions, part of the problem that he solved, by the way. Adelante, José.
Sí, vamos a ver. One moment, vamos a ver. ¿Dónde está aquí el pine? One moment. Vamos a ver. You have one pilot, another pilot, another pilot, another pilot. Bueno, lo he hecho un poco. Bueno, okay. This is the pilot reference, and here is the data, for example. De data serán, vale. Vamos a ponerlo en rojo. Ok. Más o menos. Ok. Y se supone que tiene que bajar. Más o menos. Okay, this is the pilot in the time. Vamos a poner aquí Esto, a ver. ¿Cómo se pone? Ah, vale, bien. Dime. Okay, this is the amplitude of Q and in symbols. Then and in black is the pilot reference. So you the only have to do is a linear. Esto no me busco.
That's okay.
Interpolation. Okay.
Yeah, that's the problem. You assume that the fading is linear and it may not be.
Then,
Ese es el problema, que tú asumes que el fading es lineal y puede que no sea lineal.
yes, but for that reason, you have a separation between payloads. If the pilots are enough together, this effect is, ¿cómo se dice? Despreciable.
If the pilots are together, they are. Oh, gosh, me cogiste.
That's okay. Maybe we should talk about this later. Thank you.
Interesante,
Muchas
José,
gracias,
también.
Yeah,
Te va a
muchas
enviar un
gracias,
email.
Jose. Sí.
For example, if you are doing, if you are this, here you have a problem because the pilots are too many separated. So it's not enough.
Oh, I
Okay.
see.
Here you have a bad equalization. Not good.
So
But-
Craig, he's saying that he put the pilot close enough that he can apply a linear approximation.
Yeah, he's going to have
equalization.
to do that adaptively, and that's going to cause problems. That's going to slow down the bit rate quite a bit.
That's
Yeah, that
probably the reason that he
Either
do,
that he's going to have, yeah, he's going to have to drop back on the number of carriers.
or he goes to another VARA level.
Yeah, yeah. Goes to another modulation level. Yep.
Ya.
Yep.
Ya contestamos la pregunta, José, adelante.
Sí, un momentillo, voy a hacer una cosa. And about selective fading.
Selective fading. Yeah.
Okay, this is selective fading. Okay. One moment, because here very important that I specify this is frequency. Okay, and this is amplitude. Here is even. Vamos a poner. I don't remember. For example, I don't remember exactly. And here, okay. Esto lo vamos a poner bien. Okay. Okay, this is selective fading. Each subcarrier has his own pilots. So the equalization here is different than equalization here. As subcarrier are very narrow, and subcarrier are very narrow because the symbol rate is very low, and then we can do an optimal equalization in each subcarrier. This is
Craig, do you
what
follow now?
this is what this is the problem of single carrier, okay? And with narrow spectrum, it's very easy there with the fading. with the selective fading.
Yes, thank you. I'd have to see the formulas you use for the determining the quantization, the equalization between the pilots to know what the goodness of fit would be for the estimation of the carrier amplitude between the pilots. So thank you. Let's get into that later. Let him go on to his rest of
It
the
has been a
slides.
good argument, Craig. En José, es una muy buena discusión, pero se va a comunicar contigo privado.
Vale, de acuerdo.
Okay, he said that he agreed that the discussion can be continued later on.
Thank you.
Okay. More question?
Any more question? Adelante, José.
Okay. In VARA high frequency, there is two different modes. The VARA
2,300 or 2,300.
2,300, yes, and 500. And this is the symbol rate. Maximum is 19.4. And there is 16 levels for VARA wide and 15 levels for VARA narrow. This VARA narrow is for the narrow bands on 40 meters. 40 meters, okay. Okay. This is VARA high frequency. In VARA setup, you can, this is the TCP ports. By default is this number. You have no modify anything. Here is the VARA licenses. And this is a new option. Allow VARA check for updates via internet server. Okay, when you open VARA connect with a server created by me. And with this option, the server says if you are using an old version or a new version. This is gateway compatibility. This option is because if you have a gateway using VARA 2300, you can accept narrow connection. This is a new option that is not available yet because I am working on it, but into some days I will upload a new version with the AH4 tuner enhancement. This is one option to fix one problem with this tuner. In this option, the gateway reply with a single tone to fix tuner crashed using this icon AH4 tuner. And this option will be available into some days. And this is for sending an ID. In the case of USA hands, this option is false. And this is the release that you know what is it. Okay, some question here.
Any questions, guys? Adelante.
Okay.
Question here.
Steve has a question. Jose, Steve tiene una pregunta. Go ahead,
Yes.
Steve.
Please explain a little bit more about the gateway compatibility. If you set up a FM gateway for the 2300, does it automatically switch back and forth between the 500?
This is for, Steve, this is for VARA HF.
Okay, all right, that doesn't apply then. Thanks.
Doesn't apply to FM. Isaac, you have a question?
Yeah. I'll speak a bit slowly so you can hear. Sorry, I have speech apraxia, so bear with me.
Sure.
I am a member of the sorry, is there a way that I can get in touch so I can have time to think about my question?
Sure, by email. You can send an email to Jose, and probably Dan can, when he send the videos and the chat, you can get the email and write to Jose directly if you wish.
Okay. I'm sorry. What was that?
You can contact Jose by email.
Okay.
I love it. You can see his email on the screen, and it's on the VARA, about the VARA. His email is public.
Okay. Hold on. I need to write that down.
Can we put
It's
that on the
also,
chat?
yeah. It's also on the chat. Okay, Jose.
Okay, got it.
Thank you.
I got a question.
Clem, you may
Yeah.
have many questions.
It goes back to the original question that the individual asked, but you said FM. This is, I know, regards to HF. So is it here in Hawaii, our tri-mode gateways also have, the narrow and the wide, the 2300 and the narrow one. Is it recommended that we click off that compatibility, gateway compatibility?
That is in FM, Clem?
No, HF. Our tri-mode gateways are both have the 2300 and the the 500.
Yeah,
Is it
let me
click on that?
Let me translate to Jose. Just a second. Jose, Clem from the Hawaii está preguntando que si es recomendable mantener encendido o apagado la configuración del ancho de banda de 500 Hz o de 2300 Hz. ¿Cuál es tu recomendación? ¿Y entonces se quedaría en wideband en 2300?
Yes.
The answer is to keep it off, Clem. And ¿por qué? ¿Porque es automático?
My recommendation is that if you have a gateway operating in white bandwidth, you should not, o sea, no deberías de, te lo voy a traducir en español para ir más rápido.
Sí, claro.
No deberías de permitir que la gente se conectara en 500, porque el 500 es, o sea, el modo ancho es más eficiente que el modo estrecho. Entonces,
Okay.
Alguien que necesite un minuto con el modo ancho puede necesitar 2 minutos o 3 minutos en modo estrecho. Por eso, no es bueno es mejor no permitir esa opción, y el que se quiera conectar, que se conecte en modo ancho. Y el que no se conecte.
Clem, his recommendation is the wider you keep it, the best signal to noise ratio and the data transfer is better. So he recommended just to, on the gateway, to check it out. I mean, do not select the 500 and 2300. Sort of everybody connect in the 2300, and that would improve the transmission even in the worst cases.
Okay, so keep it on check is the recommendation. But if you're going to VARA, like P2P, peer-to-peer on 500, then that's
your option.
the option. Okay, so best to not check it then.
Yeah, but he recommends also the better signal to noise ratio, the wider, the better.
Roger, got it.
The 500 hertz is to comply FCC rules and regulation for the narrow data.
Okay, got it.
All right, gracias, Jose.
More. Okay, here more question. Somebody is using this tuner.
This is Dave. Enhancement, and I have found it an improvement on the LDG tuner on incoming calls because it's been having problems tuning my antennas when there's an incoming call and they're making a call. It misses a call, but the tuner seems to be locking on a lot better on the testing that I've been doing so far. So far, I'm very happy with it.
José, David está bien contento porque no pierde esa primera llamada y sincroniza correctamente. La experiencia que ha tenido con esa opción del H4 Tuner Enhancement.
Pero, perdona, ¿con quién estoy hablando?
Who was the guy from the Army Mars?
It's Air Force Mars. Air Force Mars.
Yeah, David Webb.
Okay. Okay. Yes. Yes. I send you this a text version with another message. In your version, I write add to option or add to single tone. I don't remember.
Okay, well, we're talking about it in one direction. You have it working on receive only right now. I requested that you put it so I could make a separate option for transmit also. But so far, it seems to be working fine the way it is. So, you know, I'll leave that up to you. You're doing a wonderful job for us, Jose. I really appreciate it.
¿Traduce, Oscar?
Él, aunque te pidió que lo hiciera transmisión y recibir el tono, el túnel aparentemente está trabajando correctamente con la opción que tienes actualmente. Y te felicita por el excelente trabajo que estás haciendo para todos nosotros.
Thanks a lot, Dave.
Thank you.
Thanks a lot.
Adelante, José.
Okay.
Sigamos.
Oscar, there's a question in the chat from Bruce in San Diego. There's a question in chat.
Go ahead.
Bruce in San Diego.
Bruce?
Yes, I'm here.
Okay.
Yeah, I put it in the chat because I wasn't sure my voice would get through. There's so few internet gateways for VARA FM. And is it possible to pass VARA through a standard voice repeater that requires a PL tone? Would that PL tone mess up VARA? And what setup is needed by the repeater operator to make that repeater pass VARA traffic, and what through speed is possible?
José, Bruce pregunta si es posible de transmitir VARA a través de un repetidor de FM, repetidor de voice, que tenga también un tono de PL, de estos subcarriers.
I don't know if the delay is enough or not. Si tiene un tono de subcarrier, habrá que enviar el tono de subcarrier, me imagino.
Sí, pero si lo interfiere para VARA, aunque el tono de subcarrier es menos de 300 Hz.
No, VARA start in 250 Hz. The tone interference is not a problem.
So the interference is not a problem with the subcarrier. ¿Puedo hacer un comentario para general? ¿Tú
Sí.
en algún momento piensas desarrollar VARA para un digipeater?
O sea, crear un digipeater para VARA sería. Sí, sí, lo tengo pensado.
Guys, Jose's thinking if he start working into a VARA for making a VARA digipeater, so he can take care of the transmitting faster into the packet word with
Sí,
the VARA.
Lo que pasa es que él está preguntando por un voice repeater,
Sí.
un repetidor de voz ya existente. Entonces, sí, en VARA Narrow sí es posible.
Y ya contestaron que sí, que hay otras personas que lo han hecho.
No.
Any more questions, Dan?
I'm just seeing some down here. Dale is talking about latency and the repeaters might be a problem. And then also somebody asked if this information about the AH4 enhancement is going to be posted someplace.
Ok. Pregunta que si el tiempo de respuesta al repetidor puede ser un problema y si vas a postear lo que significa el H4 Tuner Enhancement, si lo vas a postear en algún sitio explicando qué hace para otras personas aplicarlo.
Vamos a ver, la primera pregunta era...
Si el latency del tiempo de un repetidor sería un problema. Un voice repeater.
Yes, depende cómo el repetidor esté construido. El squelch tendría que estar abierto en el repetidor.
So the answer is that the squelch control should be open on the repeater to reduce the latency, and probably open the repeater with the PL tone. Actually, we do that.
Bueno, sí, pero bueno, estamos hablando, eso era para un gateway. En el caso del repetidor, hay gente que está usando VARA sobre el repetidor de voz y no tienen problema.
So he answered that the people are using VARA over voice repeater and they have no problem. That's the answer.
I recommend you you contact with Oliver, Kilo 6 Oscar Lima, India, and you ask about repeater experience, configuration repeater experience.
That's clear. Dan, any more questions?
Yeah, just a comment from Jim, W2JC in North New Jersey. He says that they're using repeater W2MPT in FM repeater, and they're passing Winlink through it very successfully, no problems. And that's what I have for right now.
That's good. So, podemos conseguirla José, adelante. Y gracias por tus contestaciones.
No. Seguimos, ok. Ok, after son
No te escuchamos, repite.
Do you hear me?
Yes, sí, ahora te escuchamos.
Ok. In shortcut menu, device input and device output. Here the sound card. This is very easy. But this is the drive level. This is the most important configuration in VARA HF. Using tune button, we generate a text tone, and we can adjust the ALC for about 1/3 or the half of the scale. One moment, porque ahora, one moment. A ver. A ver. Okay. Here I press two button, then I can adjust the ALC. If
So
the
you need,
level is low, I have no power in the rig, and if the level is too high, I have distortion. So you have to move this dive level until have about 1/3 in the ALC scale.
so guys, you have to adjust the ALC of the radio by going to the sound card option of the VARA menu and select tune and adjust the drive level of the sound card up till you get 1/3 of the level of the ALC, and that will work perfectly for your radio, and that's your setting for transmitting. Simple as that. Adelante,
Okay.
Jose.
Okay.
Brian says that is very important. Brian dice que es muy importante.
Yes, it is. And this is the with these two menus, VARA is perfectly ready to work. The other menus are very easy. Okay, but this is this don't need presentation. This is the log. Monitor. This is one option to monitor other station, the information on other station. In case of the other station is working as public. In ham radio, usually is in public mode. But if you are not in ham radio and commercial radio, you can select private mode, and the private mode, the signal, the text don't appear in the monitor. And he has the help menu. In the help menu, we have VARA kit guide. He explained the VARA license, VARA folder where VARA is installed, the rig settings, the waterfall. The waterfall has two red lines, and the signal the signal should accept the red lines.
Te puedo hacer una pregunta. La llave de VARA, la licencia VARA, permite utilizar todos los software de VARA.
Correcto.
Déjame decir eso, que es importante. Guys, if you get a VARA license, you can use any of the VARA software because it will work because you already have the license to all of them. VARA FM, VARA VHF, VARA satellite, VARA terminal, VARA chat, and things like that.
This. Okay. Okay. Okay, some is probably to have problems with Windows Defender and files positive. Then in here explain how add one exclusion to Windows security. And also, Windows Defender have one option. If you have problem download or installing VARA, here you can submit a file for malware analysis. Home custom. You set Windows Defender, set the file, for example, I'm sorry. For example, VARA docx This is typical VARA.x that has false positive in any antivirus. Then you have put the detection name, virus, say lo que sea. And then you continue and you press submit, and the Microsoft reply to you if it's a file is positive. No. Okay.
Déjame explicar. What Jose is explaining, if you get a virus announcement or something like that from any software, you can submit that to Microsoft, the software itself, and so you can double check that VARA doesn't contain a virus. I mean, many virus protectors are actually, when there's a new software not certified by them, they will come with a flag that it can contain a virus. So, and every software have a submission of the file to see if it's really a virus or not. And he's very sure that it will come back clean. So you can double check that if you have any problem or doubt about it. So this is widely used. Many softwares having these problems with the different antivirus worldwide. Preguntaron, José,
sí,
que cuánto vale el software y si lo vas a escribir para Linux, como para la Raspberry Pi.
Vale. At the moment, I have no provisions for Linux, and the software is $69, and you have a link. In the link, you put the CalSec, press buy now, buy with PayPal. Then when you pay on PayPal, I receive the notification, PayPal notification. Then I read with the registration key.
Call sign.
Okay.
Adelante, José.
Okay. We continue with the VARA quit gate. Or git. Tune button. This is what I have explained. This is very important again. And this is a problem of some card interface that use some kind of audio transform that filter the signal and signal. So this is not good because this is a handicap. Before the signal is attenuated by the ionospheric, you start with a handicap. So what we want is start from a perfect sound card interface. Si lo puedes explicar.
Yeah, guys, you have to go into the waterfall and look into the sound card or the audio performance in the width. So if you have, like, when it says a bad sound card, it can have limiting or actually cutting off some of the bandwidth, and that's not a good sound card. You have to change your whatever, your sound card, what that is bad, and that will take care of the problem. There are plenty on the market that you can buy, and that will solve your problem and increase the speed and the signal to noise ratio as well. So you have to be aware about this imperfection. It's not the software, it could be the sound card. So you have to double check that it's working well. So this is a good advice from Jose to everyone, including myself. Adelante.
Okay. Okay, here I put some samples of very cheap PTT sound card interface. This is, for example, this is the minimum required for VARA. This is a simple interface that switch the PTT. This is about $50. So if you have no any interface, with $50 of interface and $70 of VARA, you have a digital communication system.
Adelante, José.
And here the cable for the issue, for beacon.
Perdí tu audio. Está bien bajito.
Vamos a ver.
Se bajó el audio.
One moment.
Ahí ya. Ya está de nuevo.
¿Ahora?
Sí. Ya
Ok.
está de vuelta. Sí, perfecto.
Vale. Algo pasa. Bien. VARA view meter, and you have to avoid the red zone. And the input audio is adjusting in the recording properties. Here, recording properties, and I don't know. And you adjust the level in this meter. Okay, the center frequency is USB dial plus 1500 Hz. SDR latency, he speak about SDR latency decrease the throughput. Linux, the Linux, if you have question about VARA and Linux, I recommend contact with Steve. And this is the VARA application with VARA modem in this moment, BBQ, Winlink Express, Remote, Packet, VARA Chat, and VARA Terminal. This is my mail for technical support. Okay.
¿Podrías hablar de la comparación? ¿Podrías hablar de la comparación de VARA con Pacto 4 y con eso terminamos? Porque está quedando muy bien.
Vale. Ok, bueno, terminamos con VARA HF, ¿no? Quedaría hablar de VARA FM, pero antes de terminar con VARA HF. Ok. Now, I don't know if you know this simulator. He done, let's say, did a comparison using this 10C Ionos simulator. This is the simulator, and here do comparisons, Factor 4, VARA, Factor 3, R.dot, Winmore. Okay. Then this is a simulation, and then the question is how is in the real life? If the real life is near to simulation or is very far to the simulation, then what I contact with some guys that using VARA and using Factor 4. And the first email I wrote was to Australia. This man called Lekan, and I asked to this Han, please, if you can do a first approximation to know how is the real life, the real comparison in a real path using real rigs. This was the first email using a 5 kilobits file on 40 meters. and VARA completed 1 minute, 18 minutes.
18 seconds.
Sorry. And second attempt, Dragon Model, 4 minutes. And this is the bytes per minute. 400 in the case of VARA, and only 200 in the case of Dragon Model.
Yeah.
So this is only a first approximation, but we start to see in the real test that maybe the simulation is not say the reality, no? Okay, this is the first email. After I have second email with better conditions, say 5 kilobytes file, 21 seconds, and VARA 50 seconds, and here the bytes per minute. So again, we start to suspect the real life is not exactly like the simulation sets, because here even VARA is faster. Okay, this is the comparison in Australia by horse. I contact from Austria. This is the Kalsik. He this time he has done a more long comparison, alternating several transmission. VARA pastor, and finally get the mean value in both cases. Here is the result in time, in bytes per minute. This is the number, and this is the main value. So you can see we have similar speeds. That is not like we are suspect again the comparison is not very good. This is a nice comparison by this is not ¿cómo está? Que no se acorde con la realidad, ¿cómo se dice?
That the simulator do not perform correctly as being in the reality of the air by radio. So the actual radio measurements and speed, they compare the VARA with the factor 4. That's what Jose is saying.
Yes. Another test. This in 80 meters with another gateway, a different gateway. We have again another. This is the table with bytes, minute, time, total bytes, etc. And we have another mean value. In this case, we have factor 4 16,000 and VARA 12,000. Okay, we continue more comparison. The third. Okay, this time with another gateway, 40 meters more. This is the value. Now we are seeing we have similar speeds. I don't know if if the people are understand what I am explaining. No sé si la gente está entendiendo por dónde van los tiros.
Yo diría que hay que esperar que ellos lo analicen y hagan preguntas en los foros.
Vale.
Y le paso la información a Oliver para defender los argumentos, la presentación de los hechos, con los hechos.
Vale.
Vámonos a VARA FM para cerrar. Yo diría que es correcto. Se nos alarga esto mucho.
Vale, de acuerdo. VARA FM, bueno, okay. Now we go to VARA FM. Bueno, primero voy a decir, first, okay, in VARA FM we have two modes, wide and narrow. The better is VARA wide, and esto lo voy a explicar aquí. VARA narrow use the typical 1,200 bits per second like packet. The bandwidth of VARA narrow is similar to 2,000 packet. And in the case of wide, the bandwidth is similar to 90,600 packet. Okay. In narrow is compatible with signaling, and in wide you need the new signaling that use black transforms, or I recommend this VARA board. This is a signaling. The problem of signaling is how do you adjust these buttons. This is difficult. And this is an area 30 board. This is recommended for VARA FM in wide mode. Okay, setup is similar to VARA HF. The sound card here, there is a difference because we have auto-tune. The auto-tune is an option when you connect with another station. Then VARA FM sending 11 signal, and then you get the response of the other station. Then automatically the data level is configured. In Scott. Is the one moment. Okay, for example, this is using auto-tune. You can have this response of the other station. This is your optimal data level, and this is the signal noise that you have.
Perdí tu audio. El micrófono como que tiene mal contacto.
Do you copy now?
Se cayó el audio.
Okay.
Es como mal contacto del micrófono, no es el volumen. A veces sale a todo volumen y vuelve y se cae.
Okay. ¿Me escuchas bien ahora?
Ahí, ahora, perfecto.
Vale. Okay. And this is the PTT. In the case of VARA HF, the PTT is done in Winlink. But in the case of VARA frequency FM, the PTT is switching by VARA. So here you can select VRA board or box, you are using signaling, CON, or CAT, you have a CAT interface. Okay. Question?
Any questions, guys?
Craig in Hawaii has a comment.
Go ahead, Craig.
I use a signal link for both HF and for VARA FM. And if I want to use HF, I need to leave my signal link on the 1200 bit per second pin. And I'll point out that if I were to switch to the 9600 bits per second pin for my ISU 857D, I would have to have a large file to transfer to get the throughput, the max throughput of the VARA capability. So for example, if I've got capable of 25 kilobits per second, I need a large file to come down to achieve that. Otherwise, if I'm sending out emails, I'm sending out maybe 100 bytes at a time, and then I'll have to do the turnaround, receiving and transmitting the ACK, and then getting the permission to go ahead and transmit again. That's going to cut down my throughput tremendously. So if you're worried about VARA FM wideband and you do HF, I would say unless you're transmitting huge files, don't worry about VARA wideband FM. Did I confuse people?
You said you were making a comment and now you have a question, and I missed the question on the last sentence.
So am I confusing people? Did anybody understand what I said?
Remember that when you are in VARA FM, you can transmit at 9600 port, either of both, 1200 or 9600.
Yeah, it's the signal link. It's the signal link configuration that I have to change to get to the 9600 baud port.
Exactly.
The 9600 pin.
And I think they sent an email with a protocol of how to do it. They have been,
right.
I read it about a couple of weeks ago.
Well, if I'm doing HF, I can't change the pin to the 9600 bits per second pin.
Yeah, that is different because then if you're doing HF, you have to go in 2300 hertz.
You know, I'm talking about other digital modes in HF too, like FT8.
Oh, I see.
Yeah. So that's what the point I'm trying to make. If you sending out just regular emails without a huge attachment, then FM wideband isn't going to buy you that much.
I have a question. This is Van, NH7IT.
You're doing Van.
What is the last question?
It was a comment. Era un comentario en realidad. No, y el comentario era que si tiene que enviar muchos paquetes en tamaños pequeños, pues pierde la velocidad por el número de transacciones, ¿no? En realidad no era una pregunta.
Okay.
Vamos a la próxima. Somebody had a question a second ago. Who was this gentleman, please?
It's Van, NH7IT. I have a question. As I understand, VARA HF will change the frequency on your radio CAT, so configured. Will that feature be added to VARA FM for those radios that have CAT?
José está preguntando que VARA HF cambia la frecuencia para ti correctamente si en el caso de FM que tienen CAT, si en el futuro va a cambiar la frecuencia también y corregirla.
No entiendo la pregunta. ¿Cómo que cambia la frecuencia?
Tú sabes que se corre 1.5 kHz para corregir la frecuencia, estar en el centro de banda. En el caso de FM, hay preguntas que hay radios ya de que tienen CATs para cambiar de frecuencia automática en FM, ¿verdad? Que tienen controles digitales los radios para cambiar de frecuencia. Si tú lo vas a hacer la corrección de frecuencia también en VARA FM.
No. Moment. No, only the VARA FM only switch the PTT. The frequency selection is done in Winlink.
That's the answer, Bandy. Frequency selection is done in Winlink.
Gotcha. All right, so that'll need to be a Winlink thing.
This is something that you should send an email because these are really new stuff. You doing peer-to-peer or something like that? I mean, one station A to station B directly?
Well, we have many gateways here in Hawaii, and currently they're all on the same frequency, so it's not a problem. But as we move them to their own frequencies, it's going to be a lot of dialing of the radio to test all gateways.
Yeah, that is it. You're bringing out new things, and that's very good. I suggest to write an email and explain the situation. José, yo les recomendé que en caso de Hawái, que tienen múltiples gateways, que escriban la situación, te escriban y tú veas el problema directamente. ¿Está bien hasta ahí?
Que me escriban un email, dices.
Sí.
Sí, okay, yes.
Adelante, sigue con la presentación.
This is the maximum throughput in VARA FM, obviously using the white mode. This is 140,000 bytes minute. This was a test with while I am designing VARA FM, and this is the maximum speed.
So guys, compared to 1200 baud or 9600 baud, with VARA FM, you can get to 143 kilobauds, which is impressive.
This is sending a 100 file, 100,000 file.
Mm-hmm. In 45 seconds.
In 45 seconds. Okay, yes. Here, yes, question.
This is Clem again from Hawaii. I have a question on the constellation. Hello?
Yeah, go ahead, Clem.
Yeah, can Jose explain the constellation? You know, there's different constellations showing on the, as you fire up VARA FM or VARA HF. You see the constellation above the TX delay and the signal to noise dial there on the top right side of what's shown on the screen right now. And different constellation. Can Jose explain the different constellation as it goes through the VARA?
José, Clem pregunta que qué significa las distintas constelaciones que tienes en VARA FM.
This is the constellation diagram. Is a representation of the symbols, of the signal symbols. This is a way to see the noise or the distortion. So, for example, this case is 128 QAM modulation. We have 128 levels, and this blue line are boundaries. When you see a green point in a region that is tuned to the other, ¿cómo se dice cuadrado?
Square.
A square. When one point jump from one square to the other square, you have one error symbol. And this error symbol is recovered by the FET code, by the forward error correction code. If you have a lot of symbols that jump to the one square to the other square, then the signal cannot be recovered.
José pregunta, la constelación cambia porque cambió el nivel, el level de VARA.
Yes.
Okay, Clem, the different constellation that you see, it depends how VARA adjusts his level for the maximum speed accordingly to the signal to noise ratio. So that's what that constellation represents the signal levels of each carrier. Let's say in the VARA FM you have 128, that's the one that he was showing, but it can be less carriers, and then you will see this constellation difference. Now, if you also see on this constellation the noise level, so they are representing the noise by dots that they're outside the square, crossing the noise to other square, that's making that it cannot be read. If there are few, VARA will correct them by, automatically each time that the symbol is sent. If there are too many dots across the constellation, then you have to repeat the whole symbol. So that will take care of the forward error correction. It will send the symbol again and correct it. So that's the way it follows the logic, the algorithm to get the maximum speed. What are the different levels of VARA in the constellation, and also you can see the representation of the noise of the signal that you're being received. Does that answer your question, Clem?
Yeah, I guess so, because sometimes I see an X, you know, in the constellation X, or sometimes I see two screens, left and right. Sometimes I see the whole screen, like what was shown. Yeah, that X, you see that X there?
Yeah.
Normally see that at the beginning.
Those are different levels and VARA will try to maximize the throughput or the maximum speed with depending on the signal to noise ratio that you're having from both stations.
Oscar, can I interject and maybe explain differently?
Go ahead, sir.
Clem, when you see that X is the linearity of the channel. So if you see a very narrow X, that means the channel is very clean. You aren't having any phase delays or things of that sort. The fuzzier the X is, the more difficult the channel is. So VARA FM in particular will check the linearity of the channel and try and ramp up or down to match the channel conditions. So when you see that initial X, if it's extremely narrow, that means the channel is good. If it's fuzzy, that means the channel is not so good. Craig out.
Thank you.
And the only thing I can say is really a complex software. It's simple and complex, and it's doing the right thing. Jose, adelante.
Yes. What is the question?
No, Craig answered it. Craig la contestó.
Okay. Here in this video, we can see another constellation. I don't know if you have this, ¿cómo se dice X? O aspa, ¿cómo se dice? Oscar?
Jose is asking, Clem, Jose is asking if you can see that X on your radios or your software.
Yes, I can see it, that X on the screen.
Yes, in this case, we have the most of symbol ER into the square. At low levels, here we have, it's possible that one symbol change from one square to the other square. In this case, it's for PSK modulations. For example, level 5 until level 12 modulation. in this example. Okay,
So claim,
more question? Okay, we are finished then.
so hey, guys, thank you very much. We just finished. Someone has any question to Jose? This is the good time to make them.
Muchas gracias, Oscar y Jose.
Gracias, Craig.
I do have one quick question.
Stephen?
Yes, Oscar, I appreciate it. This might have been answered, but does VARA stand for anything? Just out of curiosity.
He explained the VARA stands for the hero, a Spain hero that he used a whip and he correct things. And this is much longer than that. But it's just the name of a Spanish hero, like a Superman. That's what, and he used, VARA means stick in Spanish.
Okay, very good.
So he uses stick in Spanish and he corrects myth and things like that.
Okay, outstanding. Thank you, sir.
I have a question, WA6DNT. Oh, you guys went away, looks like.
Go ahead, Bruce.
Okay. I'm running VARA FM to on a 30-mile path to a gateway DRA 50 modem, so the modem's no problem. The best speed I can get on VARA FM is about 4,000. I never get that pattern, that crisscross pattern to develop, which indicates high speed. What kind of signal to noise ratio is needed to acquire the 25K speed?
All right, hold on. We make that question before. Jose, para
Yes.
VARA FM, para aumentar la velocidad, ¿cuánto es la señal que debería tener para tener señales de velocidades más altas de 4K?
De 4K.
Sí, porque él está teniendo velocidad de que los rayos están lejos y no está llegando a las velocidades rápidas.
Okay. He is using VARA narrow or wide?
It's VARA wide mode. I'm running FT7900 on a 9600 baud pin with a DRA 50, so that's all set up for wide. It seems to be the path that's the problem. I got a 30-mile path from San Diego to Tijuana. XC2 BNC is the only gateway station I can get on FM wide. And the best speed I can acquire with that path is 4,000. I never get up to 25K.
So what is your signal? Do you remember?
I don't remember. But I suspect that's what my question is. What kind of signal to noise ratio is necessary to acquire 25K of speed?
The problem is not only what is the signal noise. The problem is how is your hardware too. What interface are you using in white?
Are you asking what the height of my antenna is?
No, the hardware. What was your question? ¿Cuál era tu pregunta, José, en español?
¿Qué interface está usando? ¿El Signalin o otro?
Oh yeah. What sound card are you using, sir?
What kind of what?
What sound card you're using? What interface?
Master Communications DRA 50. It's set up for wide.
José está usando. Dale.
¿Qué letras?
DRA 50. DRA 50.
Okay. Master Communication DRA 50. Okay. Okay, this is okay for VARA.
Pues, pero él está a 30 millas. Él está a 30 millas del gateway. Por eso es que pregunta qué ¿Qué señal debería tener para aumentar el throughput? Si mal no recuerdo, tú querías 20 dB.
Yes, I think with 20 dB, you can get maximal throughput. But one question. One moment, please. Are you use this auto tune button?
We have, when I was initially setting it up with a station in Tijuana, yeah.
¿Qué ha dicho Oscar?
Sí que lo ha usado.
I think,
Sir, what is your
I just think it's
signal
probably,
to noise
I do not
ratio?
have a line of sight path to Tijuana, and it's a 30-mile path, so I suspect that's what's intruding on the.
No, yes,
the
and
problem.
Jose is asking if you do the auto tune, you need to know the drive level and the signal to noise ratios in the B. And if you see this, what is showing, if you get 20 dBs or higher, you're going to get a higher speed. If you go below 20 dBs, and I know that another gentleman, he was working 70 miles path with 11 dB, but it was slow. Because it's a compromise, as the signal drops down, then your speed drops down as well. So you have to give this number, the signal to noise ratio, what it says there that you can see on the screen. Here in this case, it's 33.2 dBs. So that's and you have to be 20 or higher to get the proper speed that you want to work with.
Okay, that's what I was looking for. Thank you.
Gracias, Jose. Yeah.
One moment. My question is: Are you using this function level evaluation?
The question is if you already run the auto tune and got the everything set.
Initially, I did. I haven't done it recently, but yeah. But now I know I need to get at least a minus 14, a minus 20 to get a good speed. So
No,
that's
signal to noise ratio 20. 20 or higher.
Yeah, 20 or higher.
20 or higher.
20 to 30. Yeah, okay.
Yeah. But the VARA, when you work on wide, even at 70 miles away and signal to noise ratio of 11, they have been successful to transmit files.
Yeah,
but it's much slower. Yeah, exactly.
Oh, that's much slower. Right, exactly.
Sure. But at least you're able to get the files through.
That's true. I really like the mode. We just need more gateway stations in the worst way over here to be able to pass disaster traffic. It's so hard to get gateway stations operative either on FM or HF over here.
Oscar.
Dale.
Sí, mi pregunta es si ha usado esta opción.
Dice que sí, pero no se acuerda de los números.
Vale. Si el drive level, si tiene 0 dB, puede ser un problema, pues está a tope de escala. Entonces me gustaría saber qué drive level tiene.
Okay, sir, he wants to know what drive level you have. If you use 0 dB, it's out of scale, it's max. So you have to, Jose wants to know what drive level you have. And probably you should send me an emails and share those information.
Okay, when I get to it, I'll get on that screen. Yeah, it's across the room. So yeah, I'll see if I can.
You can play. You can definitely play and get those numbers. Thank you, Bruce. Adelante, Jose.
Thank you much.
Okay, more question?
Dan.
I'm here.
Any more question? If not, it's your call.
Yeah, folks, any more questions out there? We're trying to close it out, so we better speak up. This has been a great presentation.
Carl has a question.
Oh, yes, he does. Go ahead, Carl.
Yeah, hi. I am new to, well, actually, I recently got my license and new to digital for sure. So I apologize if the question was covered or is obvious, but it's just tied in a little bit to the, I guess, the hardware interfaces, the TNCs. I don't have any equipment yet. I'm interested in VARA FM, and I'm curious. I saw, mention of the Signal Link, which I'm familiar with. And also this new one by Master Communications I just bookmarked. Two others that I have come across as I've been researching TNCs and what might work for the things I'm interested in. Two other ones that I think are newer is Draws board by Northwest Digital and the Nino TNC by the TARPN project or the TARPN project. My question is there any familiarity with those two boards, the Nino TNC and the Draws Northwest Digital TNC? And how well would they work with VARA FM, or are they not a good mix, not a good match?
What about Carl? If we ask Jose, what is one of his recommendations, things like that on the market, or because you have the board already, the interface, or you're going to buy it?
Well, my question is, I'm shopping and I'm trying to decide which boards, which would be a good purchase. And so two boards that I've looked at that I didn't see mentioned during the presentation were the Draws Northwest Digital Radio and then the Nino TNC by the TARPN project. And I'm curious if those would work with VARA, and if anybody has experience using them, or if the recommendation is purely the Signal Link or the Master Communications.
Jose and Oscar, this is Laura Cutchins. I can answer that quickly.
Go ahead, Laura.
Neither of those products are compatible with VARA. The Draws card operates as a hat on a Linux Raspberry Pi, and VARA software currently isn't available for Linux operation, so that rules that out. The other board you mentioned is a TNC, or Terminal Node Controller, which is not a sound card interface, which is also required by VARA. Hope that answers.
That is correct, Carl. So you have to go with any of the sound cards, Carl. That's the other answer. Dan.
Yes, sir. Carl, I'm assuming that took care of that question, yes?
Yes.
Okay,
yes.
Good.
Thank you.
Good. Not a problem. Not a problem. I want to make sure.
And Jose is recommending the master communication boards and the R830 and so on. Jose, adelante.
Yes, if I understand, he's asking for a TNC, sound card interface. For VARA FM, I recommend the R830.
What about the newer models, 45s and 40s?
¿Cómo recomienda las 40 y las 45 de los RA boards?
Any of the DRA boards will work fine with VARA. That's what they were designed for.
Hay otras que llevan preamplificadores. Entonces, el interfaz, cuanto más simple, mejor. Por eso la mejor es la más simple.
He is adding some, Scott, and we will need you, Scott, on this answer. Jose is recommending interfaces with less simple as possible without audio interfaces, because the audio interface brings noise into the signal. Do you have any experience on that, Scott?
No, so the DRA 45 and the DRA 50 add a preamp on the on the transmit side. I haven't seen it cause any problem at all. They work very well.
Okay. That's good to know. José, él dice que 40 y 45 trabajan bien aún con el audio interface. Eso es lo que dice Scott, y tú sabes que Scott también tiene mucha experiencia en esto.
Ah, yes. Sí, lo que pasa que, bueno, cuanto más si tiene más botones, más regulaciones, más problemas. O sea, cuanto menos, eso es lo que, cuanto menos regulaciones tenga, mejor, por eso digo.
Sí, lo sé.
Translate, please.
Jose is saying clearly that without less complication, less amplification, and things like that, the better the system is, because it reduces the number of noises added into the audio side. So
yeah,
definitely.
So the reason for the preamps, some of the radios when you're using the 9600 connections, you're driving the modulator directly, and it takes a lot more gain. So we found the DRA 30 and the RA 30 might not have enough gain to drive some of the radios when you're using the 9600 connections.
Okay. José él dice que por eso es que él recomienda la 40 y la 45, porque cuando trabaja en 9600 bandwidth, tiene que usar más drive, y el RA30 no tiene la amplificación correcta y no puede correrlo. Por eso es que recomienda la 40-45 o las nuevas.
Okay, but one moment, because in VARA FM you have this regulation, but if with this regulation is not enough, it's because you have to go to the window mixer, and maybe you have the window mixer here, then the audio is not enough. But if you have the window mixer on the top of the scale, then you have more drive level. So the problem that you need, you say that you have a problem with the drive level, that is not enough, maybe because you have in the window, you have this control in the sound card, you have this control very low. I don't know.
No, that's not the issue. It's just about, if you look at the specs on some of the radios, they require up to 2 volts peak to peak when you're driving the 9600 leads, and that's you can't.
José, hay radios que necesitan 2 voltios peak to peak y no es suficiente el RA30. Por eso es que Scott recomienda el que tiene el amplificador.
Okay, 2 volts is too much. Okay, yes. In this case, okay, yes.
So everyone, Jose agrees with Scott that if you need that drive level and the right level to drive the 9600, then you have to go with that one, with the one recommended, 40, RA45 or 40 or whatever, Scott. I think Scott will be in one meeting later on. He will talk about audio interfaces. Any more questions? Dan, it's all yours.
Okay, gentlemen, ladies, all, I appreciate you. I'm going to lower Scott's, Jose's screen. And there I am. Okay.
Now I can watch 2 people for the first time.
They're smiling.
Scott Curry, hello. And Lord,
he was talking to you.
No, I don't know. Hello.
Good to see you, Jose.
This is the problem of cannot watch the people in the TV. Now, yes.
Well, we're going to have more of this kind of stuff going on as we go down to week to week. Hopefully, Scott's going to be one of our presenters and be a part of that. He's comes highly recommended and has a lot of information to share. Jose, I really appreciate you doing this. You went above and beyond. And Oscar, I appreciate you taking your part in that too. So thanks both of you. I'll put a
Jose,
shout out.
tu trabajo ha sido excepcional. Te damos las gracias de todos nosotros. por el desarrollo y la presentación muy técnica. Nos ha instruido y nos ha aclarado tantas dudas de cómo trabajaba VARA y qué tan interesante e inteligentemente está hecho. Te lo agradecemos. Vamos a hablar más de los interfaces por Scott más adelante en otro foro. Te voy a invitar para que estés si quieres estar. Y de nuevo, muchas gracias por tu trabajo, no únicamente la presentación, sino el trabajo que ha hecho para todos nosotros en las comunicaciones.
Thanks a lot, and thanks for participating in this presentation, and thanks to you for the translation.
Buenos
with
días, que
translation
tengas un buen desayuno.
Yeah.
Hay un desayuno ahora.
Now here is 5 in the morning.
Good morning.
Thank you, guys. Have a good night.
Yes. Oh, I understand Jose is going to send us the PDF copy of his presentation.
Yes. José, yo le puedo pasar la copia de tu presentación, ¿verdad?
Yes, of course.
I have it done. I have it already. I will send it to you right away.
Okay, thank you very much. I'll get the thing of this movie or this video put up, make it available to everybody. Again, thanks for showing up, everybody. There's a lot of chat still going on. I'm going to kill this thing so that Jose can get to bed.
Good night, everybody. Thank you all for coming.
Yes.
73.
Stay safe, guys.
Thanks.
Muchísimas gracias, Carlos y José. Que la pasen bien ustedes.
Thank you. Aloha for Hawaii.
Aloha.
Mahalo.
Aloha. Thank you.
73s, everyone.